and that sets it equal to each other, all right? So inequalities are solved the same as equations, except, big word, except, okay? When you multiply or divide by a negative number, you must flip the inequality sign. Did you learn that in 7th grade? I got one yes. At least I got a head nod today. Inequality is a mathematical sentence that compares two unequal expressions. Uh-oh, here's your notes. Sir, there's no more up there because I had to make, oh. You took his notes. I didn't just diss you. Here's a chart of words or phrases associated with the inequality symbols. So what is this symbol most known as? Okay, less than. It also can be referred to as is fewer than. Okay? This one, less than or equal to. Also, at most, we use that symbol. We use that symbol for no more than. These are just the most common ways they're referred to in a word problem. Maximum value. Okay? It's not all of them, but the most common ways you will hear it. So this one is just the opposite of less than or equal to. It's greater than or equal to. At most, the opposite of at most is at least. Okay. The opposite of no more than is no less than. Okay. And the opposite of a maximum value is a, anybody guess? Minimum value. Okay. And this is the opposite of less than. This is greater than, or less, opposite of is fewer than is more than. Just some of the ways you will hear these signs referred to in a word problem or an everyday life situation. An open dot, meaning if you circle some point with an open circle on a number line, means the number is not part of the solution set. Thus, it is not shaded. The open dots are less than and greater than used for, I guess we could write that word. Use the open dots are, that doesn't make sense, but use the open dots when you have problems that are less than, greater than, and not equal to, okay? You use a closed dot on that number line means the number is part of the solution set, thus it is shaded. The closed dots are less than and equals to, and greater than or equals to, or equals to. On a graph, you will see a dotted line for that part, and we will go over that. You'll see a dotted line for this, and you'll see a straight line filled in for this, okay, on a graph. Verbal description, so x is less than 2, x is less than 2, you would go to the number line where 2 is, and you would put an open dot, and then you would put your arrow going less than. Okay, x is less than or equal to 2, here's a closed dot, and it's going down, meaning it's less than. X is greater than 2, it's going this way, and it's open. X is greater than or equal to, it's closed, and it's going this way. Special case symbols. Remember I told you yesterday that that symbol means all real numbers work graphically as this. All right, so this is the symbol for all real numbers on a graph. You just write on like a number line, you would just put this across your number line, okay? This means no solution, no graph, since no number works, okay? What do we know those as? Let's do an example. 6 is less than 3. Is that a true statement? So it's the empty set, isn't it? So we call that the empty set, no solution. Any of those terms work, because what if it was 6 is equal to 3? Same thing, correct? Okay. Everybody good? Okay. Slowly retreat. All right. It looks like a lot, but these are pretty simple things, okay? It says, example 1, translate and graph the solution for the set for the following sentences. A number Q is less than 2. So how are we going to write that? Q is that less than, that's the translation, 2. Then it says to graph it. So are we going to do an open circle on 2 or a closed circle? Open circle on 2, and then we are going to go which way, left or right? And you can do it, I don't care. You don't have to make the big old thing like this. It doesn't have to be all that pretty. You can put one line down and put an arrow, as long as I can tell that you were going to the left, okay? So next one, given the following equality, write a word sentence and graph the inequality. So now we need to write a word sentence. A number x is greater than -4. Okay, so it's just the opposite way of doing it. So I've got an open circle on number 4, and I've got a line going this way, indicating where I want to go. Okay? Everybody good with that? Now it says, given the graph, write an inequality and a word sentence. Oh man, they're making us work too hard. We have a closed circle on what? Okay, so it obviously is including 5, and it's going left, so that means it's less than. So we're going to write x is less than or equal to 5. And then what I just said as I was writing it, you could say a number x is less than or equal. Why do I have a red light? Aren't I supposed to have a green light? Okay. Equal, I just noticed that. Equal to 5. And there are different ways you could write that. I could write it a number is at most 5. So you could use any of that terminology from that we gave you on that first page. You notice one is much shorter than the other, isn't it? Okay, but whatever way makes you happy. All right. Okay. Either of those answers are correct and acceptable. All right. So see, like I said, it looks like a lot of paper, but it isn't a whole lot of work. All right. Given the word sentence, inequality or graph, write the other two representations. So y is less than -4. How are we going to write that? And the less than symbol is -4, right? Okay. Now, you got a number line. Sometimes they're going to give you a number line. Sometimes you need to create your own. Don't go overboard with the number line, okay? Make this as simple as possible for yourself. If they give you a number line, pick a spot. It doesn't matter where you pick the spot. I really don't care, okay? And then just give me 0 so I can kind of tell 1, 2, 3, 4. So this is where I'm going to claim -4 is, and I'm going to put an open circle, and I'm going to say going this way. Okay? K is no more than 7. So what symbol are we using? K can be no more, but it could equal 7, couldn't it? All right, 7. So here again, this time, since I've got this, I'm going to put this here. 1, 2, 3, 4, 5, 6, 7. So that's my 7. And this time I need a closed circle. Now, which way am I going to go for this one? To the left. Okay? I obviously don't draw pretty. Okay? P has a minimum of -5. A minimum. So am I using a greater than, less than, greater than and equal to, or less than and equal to? Greater than or equal to -5. So you see, I'm changing my number line at my whim and just making it wherever I want. 1, 2, 3, 4, 5. -5 is here. Am I going to have a closed circle or open circle? Closed circle. Am I going to the right or to the left? Right, because -5 is the minimum. Okay? Now, if they gave me well, we're not going to go there. An interval, it'd be different, but we're not working on that yet. All right, x does not equal 0. So I can pick a spot and put 0. Is it going to be open, closed, what? Okay, open for 0 because it can't equal 0. And I'm not being perfect. Obviously, my circle includes 0.1, 0.2, whatever, okay? I just want the gist of it. Let's put it that way. All right, now, where am I going to go with this arrow? Anywhere. So, it could be greater than 0, couldn't it? It also could be less than 0. It just can't include 0. So, a number x is not equal to 0. Okay? Everybody good? X is greater than or equal to 1/2. Okay. Then I would do this. 0. I'd make it so that it's easy for me to read. I'd probably go 1/4, 1/2, 3/4, and I'd put a 1 here, and I'd come here and do 1/2, so that it's, you could do it in between those two little lines if that was what was given to you. You can do it however you'd like. I need a closed circle, and I need to be going which way? To the right. Okay, these are pretty easy. A number x is greater than or equal to 1/2. Okay. Oh, now I got to write the expression. So what is this telling me? X is what?
Greater than or equal to -1.
So X is greater than or equal to -1. Okay, so a number X is, how else can I write that? At most, would that work? Would at most or at least?
At least.
At least, very good. Okay, at least -1. Okay, how about the next one?
X is equal to.
Equal.
Yeah.
Ooh.
It's less than 3.
Less than 3. X is less than 3. So how would I write that? A number X is, we could use at most. No, it isn't at most. It has to be something other than that, right? Less
Fewer.
than, or is fewer than, less than 3. Or is fewer than 3. Any of those would work. Okay. See how quick this goes. Oh, we only got like 4 more pages. Okay. Solving inequalities. You can solve inequalities the same way you solve equations, by using inverse operations. The only difference is that you are not finding one solution for the variable, you are finding infinitely many solutions. Hence the reason you graph the solution on a number line. 2 less than 3 times a number. These don't go away. X is less than or equal to a -14. So I got 3 times a number, right? And I've got less than, those wonderful words again, which means I'm going to put that 2, I'm going to subtract 2 after the variable. Okay, so I'm going to do subtract 2 is less than, okay, so less than or equal to a -14. There we go. Okay, so I've got 3x minus 2 is less than or equal to a -14. So add 2, both sides. I get 3x is less than or equal to a -12. I divide by 3, just like always. Do I need to flip my sign? When do we flip our sign? What did it say? Let's go back and look at that. It says when you multiply or divide by a negative number, not when your solution is a negative number, okay? So we do not need to flip the sign because we are not multiplying or dividing by a negative number, so x is less than or equal to -4, okay? So I'd go to -4, it has to equal it, and I'd say, okay, I want to go that way. Okay. All right, let's look at the next one. 3 is greater than or equal to 4d plus 7. Okay. I'm going to do what? -7. I get 4d is less than or equal to -4. Divide by 4, and I get d is less than or equal to -1. Now, these are very difficult to read in this format, okay? You will probably go the opposite way. So in this instant, I would say take your d, make sure that you have the symbol facing the d the same way, and change it, okay? Because most of you will probably go greater than if it's facing that way. So this way you know it's d is less than or equal to -1. You noticed when I said it the first time, I said it as d is less than or equal to -1. But it's very easy to get it flip-flopped in your head. So I need -1, and it's going to be possibly equal to that. and I need to go to the left. Okay? See, there's only a couple problems on each page. That's why we have so much stuff here. It says, so far you've not run into any problems with regard to solving inequalities and graphing them. The inverse operation has worked thus far. However, when you divide or multiply, here again, by a negative number, it requires a little more work to get the appropriate answer. Solve and graph the solution set for the following problems. All right. So remember, we are going to flip the inequality sign when we divide or multiply by that negative, okay? So I've got negative 2x is greater than 6, all right? Divide by negative 2. This is where you need to flip your sign, okay? So I get x, because I need to leave this positive, is equal to, is less than, negative 3. So pick a spot, 0, 1, 2, 3, negative 3. I'm going to open circle, and I'm going to say it's less than. Okay? All right, 2h minus 13. Is this pretty straightforward so far? Anybody having any problems with this? Okay. Not going too fast then, right? Just checking. Need to check. You guys are so quiet. I'm used to a rowdy group here, okay? Those of you in my classes know that this is very, very quiet, isn't it? All right. Add 13, add 13. I know I have serious students in here. I've got 2h is less than, what do I got here? Negative 10. Lord have mercy. And then I divide by 2. Do I need to flip my sign?
No.
All right. H is less than negative 5. Okay. There again, pick a spot. I don't care where it is. 1, 2, 3, 4, 5. Indicate where it is. I'm going to do open circle, and I'm going to go this way. Okay. Special cases. We always have to have special cases. All right. Algebraic method. We just dealt with this. I'm going to rewrite it for x is less than or equal to negative 7 plus 4x. Oh, I can see something's going to happen. What's going to happen?
It's going to be no solution.
Look at this. All right? So when I subtract 4x from this side, subtract 4x from this side, I get 0, let's see, is less than or equal to negative 7. Is that a correct statement?
No.
True statement or false statement is what I'm asking. It's false, right? Let x 0 is not less than or equal to negative 7. So this is the empty set. Or you can also say that as no solution. And the reason I keep putting both down for you is because I've seen some problems and some questions where they give you the choice of no solution. I've seen some where they give you the empty set. I've seen some where you see it like this, okay, as an answer choice. So I want you to, that's why I keep writing them all down so that you will know. All right? Let's look at this one. 5x plus 7 is greater than, 5x minus 8. I wonder what's going to happen here. Subtract my 5x. Whenever you see your two variables are first, go ahead and do that first instead of your constants, all right? Probably should teach you to do equations doing your variables first, and then you would have that habit. Now I end up with 7 is greater than negative 8. True statement? So that is a true statement. So what is my solution now? What was it yesterday? Okay. All right. I got infinite number of solutions. That's a long way to run it out. Okay. It could be my solution equals that, which is what? Set of all real numbers. Okay? All right? And I see it like this, I see it like this on questions, and that's why I give it to you. I try and keep giving it to you in the multiple ways that it could be answered. What do both the special cases have in common? Can you tell me what they have in common? They're special. That's good. The x terms, which are variable in this instant, correct? Cancel out, don't they? How do you know if the answer is the empty set or the all real numbers? If the statement, and just so you know, this is a sentence in math, okay? That's why we can call it a statement. Any solution is a sentence in math. It's a statement, all right? You have a noun and a verb, okay? Think about it. If the statement is true, then what do you get? Then always the set of all real numbers. If the statement is false, then always the empty set. You know, one other way, no solution, okay, like this. I think I've even seen the word null, N-U-L-L used. N-U-L-L set, I think, but not, that's really unusual, okay? I'm not going to do all these on the back. Okay, they're just practice at what graph and solve the following inequations. So I'm just going to do a couple. I'll do this one here because you guys love fractions so much. I would take this and I would multiply both sides by 6, wouldn't you? We got that by now, right? 6 over 1. It would cancel out your 6's. I'd end up with j is less than 0. So then I'd write myself a little line. I'd put a 0 here. I'd put a nice little, because it's less than or equals to, and I would draw my line like this. Okay? I'm telling you, make your graphs very simple. All right? I love fractions. You don't. I've got -3. You're getting better at them, though, huh? They're not bothering you so much? Maybe? No, I hate them still. Okay. What are we doing here? We're multiplying by a negative number, aren't we? So what am I going to have to do? Flip the sign. Is less than or equal to -18. Like I said, don't make your graphs, just give me -18 on a graph, and it says less than or equal to, so here we go, that way. Okay? Don't make yourself crazy. All right. Number 12. Write an inequality for the graph. So what is that telling me it is? There you go. Okay. All right. Good. Do I need to do more? Yes, no, maybe so? All right.